Hello everyone. So this lecture is on section 1.2, which is on addition and subtraction of whole numbers. So I want to start off by reviewing some properties of addition. So properties. Of addition. Okay, so the first property says if I take any number, call it A, so A represents any number. You can think of it as a whole number in this particular chapter, but in general, it'll be any number. And I add 0 to it, or I could actually add them the other way. I could add 0 plus A. What do I get for an answer? I get back that number A, right? So if you add 0 to any number, you just get back the original number. This is called the identity property of addition. Okay, a second property is, let's say I have two numbers, A and B. So again, these are just two general numbers, A and B. It turns out the order in which I add them doesn't matter. So A plus B is equal to B plus A. Right? It doesn't matter if I add, 2 plus 3 or 3 plus 2, I still get the same result. I get 5 in both cases. This is called the commutative property. It's really the commutative property of addition. Okay, so you can think of it as order doesn't matter. So for example, if I add 3 plus 5, that's the same as 5 plus 3, right? In both cases, I get 8. Okay, another property is the way I group numbers. As long as I'm adding them all together, it doesn't matter how and what order I add them in. So if I have A, B, and C. Let's say I do A plus B first, and I'll represent that by putting parentheses around it, so I get a result for that particular answer. And then I add C to it. Well, that's the same as if I had added B and C first. So I'll put a parentheses around B and C, and then added that result to A. In both cases, as long as I'm adding everything, I get exactly the same answer. This is called the associative property. Really of addition. And again, the way to think about it is grouping doesn't matter. Okay, so for example, let's say A is 1, B is 5, and C is 6. Okay, so what it's saying is if I add 1 plus 5 first, so obviously that's going to be 6, and then I add that result to 6, that gives me 12. Well, that should equal, on the other side, I could do this as 1 plus, and then B plus C, which is 5 plus 6. So I could add the 5 and 6 first, which gives me 11, and of course 1 plus 11 is also 12. So I get exactly the same answer, right? So it doesn't matter how I group the numbers, as long as I'm adding them all together. Okay, let's review how to add several whole numbers together. So we're going to add these numbers by hand, right? So, for example, let's say I want to add 55,998 plus 2,988 plus 3,126. Okay, so the way that you do this is you line up all the place values, right? So I'll write down the first number. You don't have to write the comma, by the way. The second number underneath it, and notice I'm lining up the thousands place, the hundreds place, the tens place, and the ones place, and then finally the last number underneath that. So I want to add these all together. By the way, these numbers are called the addends. Don't worry too much about the terminology, but so these three numbers are called the addends. And the result that we want is going to be called the sum. The final result will be the sum. Okay, and you may have learned, a different algorithm, a different way of doing this. Let me show you how I learned it. So what you do is you start in the ones column, right? So I add up these numbers in the one column. So I have 8 plus 8, right, which is 16, plus 6, which is 22. You kind of do this mentally. But I can't put 22 down there, so I put the 2 down, and then the other 2, that's in the tens place, I'm going to write that I'm going to carry it, right, in the tens column. So now I need to add up everything, all these numbers in the tens place. So I have 2 plus 9 is 11, plus 8 is 19, plus 2 is 21. So I write down the 1, and I carry the 2 into the hundreds place. Then I have 2 plus 9 is 20, plus 1 is 21 again. 1, carry the 2, so the 2 is in the thousands place now. Then I have 2 plus 5 is 7, right? Plus 2 is 9, plus 3 is 12. So I write down the 2, and then I carry the 1. And then finally, 1 plus 5 is 6 in the 10,000s place. And that's the answer. So the answer in this case would be 62,112. So you simply line up, right, all the numbers, line up their place values. Subtraction is similar, except sometimes you may have to borrow. So let's do a couple of examples with subtraction. Let's say I want to subtract 362 minus 120. Okay. First of all, these have names. This is called the minuend. And then the number that you're subtracting from it is the subtrahend. Again, don't worry too much about the terminology. I forget a lot of these terms myself. The important one is the answer, though. The answer, you should know, this is the difference. So the answer to a subtraction problem is a difference. Okay, so in this case, again, you may have learned this differently with different algorithms. But the way I would do this is, again, start in the ones place. So I have 2 minus 0. Okay, I can do that. That's 2. Next, I go to the tens place. I have 6 minus 2, which is 4. And then finally, I go to the hundreds place, 3 minus 1, which is 2. And that's correct. So in this case, the answer would be 242. All right, what if we have something more complicated where we're going to have to, borrow? Let's say I want to subtract 21,005 from 64,000. Okay, so the way you would write this, right, is the 64,000 will go first, and I want to subtract the 21,005 from that. Okay, so now if I start in the ones place, I need to do 0 minus 5. I can't do that, right? 0 is less than 5, right? You always want the first number to be larger than the one you're subtracting. So how do I do this? I need to borrow, or some people will call this to deconstruct the number. Well, normally I would borrow from the tens place, but that's also a 0, so I can't borrow from that. So I go to the hundreds place, I can't borrow from that. I go all the way to the thousands place. I need to borrow from there. So this 4 now becomes a 3, and then this becomes a 10. But I need to borrow from that 10. So really this is going to immediately become a 9. This will become a 10. And I need to borrow from that 10. So this becomes a 9. And then finally I have a 10 in the ones place. Okay. So really what's going on here is you're deconstructing. This 64,000 becomes 63,990 plus 10. Okay, and you can kind of see the 63,990 there, and then I have a 10 now in the ones place. So I deconstructed that number. So now we can go ahead and do our subtraction, right? 10 minus 5 is 5, 9 minus 0 is 9, 9 minus 0 is 9, 3 minus 1 is 2, 6 minus 2 is 4. And that's my answer. So 42,995. Okay, let's do another one here. Let's say I want to solve this subtraction. 729,888 minus 92,889. Okay, so again, I start in the ones place, but I can't subtract 8 minus 9, right? I always want a positive, at least 0 or a positive number when I do the subtraction. So I need to borrow from the tens place. So this 8 becomes a 7, and I can put that 10 now with the 8 in the ones place, so it becomes 18. So now I can do that subtraction, right? 18 minus 9 is 9. Now I go to the tens place. Well, what's 7 minus 8? I can't do that subtraction. I need to borrow from the hundreds place. So this 8 becomes a 7, and the 1's going to go with the tens place. So now I have 17 minus 8, right, which is also 9. Then I go to the hundreds place. 7 minus 8 I can't do. I need to borrow. So that 9 becomes an 8. I'm borrowing from the thousands place. So that 1,000 that I borrowed becomes 10 hundredths, right? So I basically put a 1 in the tens place. So 17 minus 8 is 9 again. Go to the thousands place. 8 minus 2, that I can do. That's just 6. And then the 10,000s place, I have 2 minus 9. I can't do that. I need to borrow again. So that 7 becomes a 6. And the 1 goes next to the 2. So I have 12 minus 9, which is 3. And then finally, 6 minus 0 is 6. So that would be my answer, 636,999. Okay, and again, you just need to practice this. And if you've learned this a different way, that's fine. As long as you're getting the correct answer in the end, that's fine. Okay, now let's talk a little bit about estimating sums and differences. Let's say we want to estimate this sum by rounding to the nearest 10. Okay, and here are the numbers I want to add together. So I have 452, 597, 401, 36, and then 43. Now in this case, right, that wouldn't be too bad to find the actual sum, right? We could do that pretty quickly, but we actually want to estimate, and we don't want to find the exact sum. We want to just get an estimate of it. Okay, and we want to estimate by rounding to the nearest 10. So the question is, how do I do this? Do I actually do the sum and then estimate? Like, do I do the sum and then round to nearest 10? Or should I round each number first, and then sum them? And the answer is you should always round first, then find the sum. So let me write that here. So make sure you round first, then find the sum. Okay, so whenever you estimate, you round first, then find the sum. So I want to round all these to the nearest 10. Well, remember how to do that from the last section? I underline the digit in the tens place. I look to the right. If it's 5 or greater, I have to round up, right? I have to add 1 to that digit, and then everything else becomes 0. If it's less than 5, that digit stays the same, and then everything to the right becomes 0s. So in this case, I have a 2 to the right of it. So this is going to be 450, right? The 5 stays, and everything else becomes 0. Okay, the next one, 597. So the 9 is in the tens place. I look to the right. It's 5 or greater, right? 7 is greater. So the 9 has to become a 10, but I can't put a 10 there. I can put the 0 there, and the 1 has to go in the hundreds place. So this, rounded to the nearest 10, this is going to be 600. Then the next number, right, 0 is in the tens place. I look to the right, I have a 1, so that's going to stay a 0. And I add zeros to the right of that. 36, well, that's in the tens place. 6 is 5 or greater, so that has to round up. So I have to add 1, and then it becomes zeros. And then finally 43, I look to the right, it's less than 5, so that stays a 4. And everything else is zeros. Then I add them together. Okay, so all the zeros obviously would just give me 0. If I add in the tens place, I have 5 plus 0 plus 0 plus 4 plus 4, which is 13. So I write down the 3, carry the 1. Then 1 plus 4 is 5, plus 6 is 11, plus 4 is 15. And that would be my answer. So 1530 would be the correct sum rounded to the nearest 10. Okay, and notice here that in the ones place, I have 0, right? This is literally to the nearest 10, which it should be. Okay, here's another example. Let's say I want to estimate the sum by rounding each number to the largest place value. Okay, so these are my original numbers. Say 5,801, 3,882, and then say 12,644. So I want to add those up, but I want to do it by estimating, and I want to round each number to the largest place value. Okay, so largest place value means, well, in the first number, it's going to be the 5, right, which is in the thousands place. So I look to the right, I have an 8, the 5's got to go up to a 6, and then everything else becomes zeros. In the second number, the largest place value is the thousands, right? The 3 is in the thousands place. I look to the right, it's an 8, so 3 has to round up to a 4. I have to add 1. So that becomes 4,000. And then finally, in the last number here, the 1, right, so in the 10,000s place is going to be my largest place value. So I look to the right, I have a 2, which is less than 5, so that stays a 1, and everything else becomes zeros. And now I can add these, and that will be my answer. So 6 plus 4 plus 0 is 10, right? So again, I write down the 0, carry the 1, and have a 2 here. So it's going to be 20,000. Okay, and then, of course, if you're finding the difference, right, subtracting, it's the same idea. So let's do one more problem here. Let's say we want to estimate the difference by rounding to the nearest hundred. Okay, so this is my original problem, 7,283 minus 4,049. So again, I don't want to do this exactly. I want to estimate it by rounding to the nearest hundred. So I round each number first, right, to the nearest hundred. So in this case, the 2 is in the hundredths place. I look to the right. It's an 8. It's larger than 5, right? Larger than or equal to 5. So that 2 has to go up to a 3. So this will be 7,300 minus, and then in the second number, the 0 is in the hundredths place. I look to the right. It's 4, which is less than 5, so that stays a 0. So this will be 4,000. And now that I've rounded both numbers to the nearest hundred, now I can do the subtraction. So this is 0, 0, 3 minus 0 is 3, and then 7 minus 4 is 3. And that's my answer, 3,300. Okay, next let's do one application of addition where we have to find the perimeter of a particular geometric object. Okay, so let's say this is the question. What is the length along the perimeter of the room below? So I'll draw you guys a picture in a second. Okay, so let's say this is the room. And we're given some measurements. We're told that this length from here to here is 5 yards. Let's say this length from here to here is 2 yards. This is 4 yards. And then let's say we know that this is 2 yards. Okay, so what does it mean to find the perimeter? It means you want to simply add up the lengths of all of these sides. Right, so each side. Well, first thing I need to do is I need to figure out, right, we weren't given the length of this side or this side, but we can figure those out. So let's start with this bottom one right here. How do I find this bottom length? Well, I know that from here to here is 2 yards, and from here to here is 4 yards. So therefore, this must be the sum of those two, right? So this length must be just 6 yards. I got it by adding 2 plus 4 yards is equal to 6 yards. So that length is 6 yards. And then I also have to figure out this length right here. Well, I know the total height from here to here, or this length is 5 yards. And if I go just from here to here, this is 2. So what's remaining? Well, it must be the difference, right? So this length must be 5 minus 2. So this is going to be 5 yards minus 2 yards, which is equal to 3 yards. Okay, now that I have the lengths of all the sides, I can find the perimeter simply by adding them all up, right? So let me start, I'll start with the top and go clockwise around. So I have 2 plus 3 plus 4 plus 2 plus 6 plus 5. Right, so I'm going to add all those together. So 2 plus 3 is 5, plus 4 is 9, plus 2 is 11, plus 6 is 17, plus 5 is 22. And then it has units, right? It's yards because it's a total distance. So that would be the answer. 22 yards would be the distance around that entire room, right? That would be the perimeter of that room. Okay, so let's finish up this section by doing a few examples from your My Open Math homework. So this first question here is simply to add those numbers together. So remember, we line everything up by the place value. Okay, so then I go to the ones place, right? I have 4 plus 8 is 12, plus 8 is 20, plus 4 is 24. So I write down the 4 and then carry the 2 to the tens place. Now I add everything in the tens place, including that 2 there. So 2 plus 2 plus 2 is 6, plus 3 is 9, plus 4 is 13. So 3, carry the 1. Now add up everything in the hundreds place. 1 plus 2 is 3, plus 4 is 7, plus 3 is 10. So 0, carry the 1. And then 1 plus 8 plus 1 is 10. So 0, carry the 1, but then I can just write it down, right? So it's going to be 10,034. Second one is just a subtraction, right? So 57 minus 24. This one's nice. There's no borrowing required, right? So start in the ones place. 7 minus 4 is 3. 5 minus 2 is 3. So the answer is going to be 33. Okay, in this first example, again, it's just another subtraction problem. So we're going to line up place values. And in this case, I do need to borrow, right? Because if I start in the ones, I can't subtract 2 minus 6. So I need to borrow from the tens place. So that 3, if I borrow 1 from there, it becomes a 2. And then the 1 goes next to the 2 in the ones place, right? So really, you're borrowing 10 because you're borrowing 1 from the tens place. So 10 plus 2 is 12, right? But normally we just write down the 1 next to it. So 12 minus 6 is 6. Now I need to do 2 minus 8. Well, I can't do that, so I need to go to the hundreds place, borrow 1. And again, really what I'm doing is borrowing 100 or 10 tens. So, but the easiest way to think about it is I just write that 1 next to the 2 now in the tens place. So then I have 12 minus 8, which is 4. Now we need to borrow from 3 minus 9. I can't do it, so I need to borrow. Well, I can't borrow from the 0, right? So I go all the way to the 10,000s place, borrow from there. That becomes a 4. This becomes a 10. And now that this is a 10, I can borrow 1 from it. This becomes a 9. That's a 1. So 13 minus 9 is 4. And then 9 minus 6, I can do that. That's 3. And then 4 minus 0 is 4. So that would be the result, 43,446. Okay, and the next question, here you have to be a little careful. We haven't talked about order of operations yet. We will get to that soon. But if you have addition and subtraction in one problem, you have to do the operations left to right. So in this case, I have to do that subtraction first. Get an answer, and then I can add it to the 53, okay? So let's do that. So I have 70, I'll do it over here, 70 minus 6. Well, same thing, right? I can't do 0 minus 6, so I need to borrow from the 7. That becomes a 6. This becomes a 10. 10 minus 6 is 4, and then 6 minus 0 is 6. So this is really 64 plus 53. And now I just have to add those two together. So 4 plus 3 is 7. 6 plus 5 is 11. So this is going to be 117. So that would be the answer. Okay, let's do one more question. So in this question, we want to find the perimeter of that figure that's in the picture. Okay, remember perimeter just means add up the lengths of all the sides, right? But first, we need to figure out the length of that side and the length of that side. Well, this side right here, right? I know that the total length from here to here is 7, right? Because that's the same as that, so that's 7. And I already know that the length from here to here is 4. So this length must be what? Well, it must be 7 minus 4, right? Whatever's left over. So that's going to be 3 in this case. And then to get this length, I use the same idea. I know the total length from here to here is 10. And this length is 3, right? So if the whole thing is 10 and this is 3, then this must be the difference between those two. So 10 minus 3 is 7. So this is going to be 7. Okay, now I can add up the lengths of all the sides, right? So again, I'll start at the top. Just be careful you don't double count anything, right? Start at the top and go clockwise around. So I have 3 plus 3 plus 7 plus 4 plus 10 plus 7. Okay, so 3 plus 3 is 6, right? Plus 7 is 13. Plus 4 is 17. Plus 0 is 17. Plus another 7 is 24. So 4 carry the 2. And then 2 plus 1 is 3. So in this case, it should be 34. And there's no unit, so we can just leave it as 34. And that will be the correct answer.